Okay, so welcome back. In this video, we're going to talk about C#, and we're going to talk about date time calculations and durations and intervals and clock times and stuff like that. It can get very, very confusing when you're talking about especially calendar stuff and clock stuff. And what I want to do in this video is try and give a good perspective and step back and say, okay, what is the stuff we can rely on and what is the stuff we have to be careful about when we're dealing with intervals and dates and calendar times and that kind of thing. Now, I encourage you, if you like this video or any of these videos, please give it a thumbs up, hit the bell notifications, and also subscribe. And especially let your friends know about it. If you know of anybody else who might be interested, let them know. It would help out a lot. So the first thing I want to talk about is the stuff we know and the stuff we have to be careful of. And I've got a little Excel spreadsheet here, and I've separated out some stuff. On the left hand is stuff that we know is fairly agreed upon around the world and fixed, and then stuff that's variable that we really have to be careful of. So what do I mean by this? Well, the fixed stuff, for example, everybody pretty much agrees that there are 60 seconds in a minute, right? And then there's 60 minutes in an hour. And there's 24 hours in a day. Generally, those things are agreed upon by anybody. I'm sure you'll find somebody who disagrees, but for most of the world, that's in agreement. And most people also agree there's 7 days in a week. Now, I'm sure you can find someone who might disagree, but these things are generally agreed upon by most people, and you can pretty much rely on them. Now, on the right-hand side is stuff that's variable. And, for example, how many weeks are there in a year? Well, most of us would say, well, 52, but then there's leap year. And then there's different calendars, so it might be 52 or 53. So it can vary depending on who you talk to. How many days in a month? Well, everybody knows there's 28 in February, and others have 30 or 31, and then leap year, February's got 29. So it can be 28 to 31. It can vary all over the place. So that's really not something that's fixed. You have to be careful. How many days in a year? Well, like I mentioned, if you have leap year, normally we think 365. Well, leap year, you can get 366. So that can vary too. And then when you get into clock time with time zones and daylight savings time, that can go all over the place. So anytime you're dealing with clock time, you've got to be careful. So the point here is that there are some things that are agreed upon and fixed and you can rely on. And then there are some things that you need to be very careful of and look at in greater depth. Now, these things on the right you may not be dealing with, so you don't care. Maybe you're only dealing with stuff in the hours, minutes, seconds, days, weeks category. And these calendars and clock times don't really matter, right? Maybe you just want an interval between, stuff that happens in 10-minute spans or something. And you don't care about these clock times and the days of the month and calendar times. Otherwise, you may really care about this. So I tend to categorize those in terms of, as you can see here, we're talking about seconds, minutes, hours, days, and weeks. When you're talking in those terms, you're generally doing pretty well. You're generally fixed in agreement. But over here, the commonality is if you're talking months and years and clock time. If I hear the term month or year or clock time, when it comes to software, alarm bells go off and lights flash, because I know that when you're talking about months and years and clock time, you can get into some trouble if you're not careful. So what we're going to do is we're going to dig into these a little bit more with a C# console application, use some of the methodology to figure out some durations and see what some of the challenges are. So what I've got here is a very simple C# console application, and not using much in terms of usings. I'm just using the system, and I've got my main, and here I have set up I've instantiated two date time objects. And DateTime is a standard C#.NET structure, and it allows you to do like date durations and intervals and that kind of thing. So I've got a date time, and I am instantiating that, and I'm calling it day 1. And I'm doing that for another one, I'm calling it day 2. Now, these two look the same. All I'm specifying is a date, okay? And in this case, I've got 2/28, which is February 28th, 2019, is day 1. Day 2 is February 28th, 2020, okay? So I've got these two objects, and what I'm going to do is I'm going to find the difference or the interval between these 2 days. Now, if you look at this date time methodology, the structure, you can see there are 11 overloads. And what that tells me is I can get really detailed in how I specify a date time object. Here I'm just using it as a day, but I can add comma, hours, minutes, seconds to specify a specific time in that day. But here I'm just using the day itself. And what I'm coming down here, I'm calculating a difference using a time span object, okay? And I'm calling it diff. And the way I do that is I take day 2, which is this 2020 date, and subtract from it day 1, which is the 2019, and coming up with a difference. And that is a time span object. All right, that's system.timespan. And hopefully it will help us figure out how many days or whatever between these 2 dates. So I'm going to put a breakpoint down here, and I'm going to run this. And here I've got, if I go up here, I go to my day 1 and I look, it is, as you can see, February 28th, 2019, and it defaults to midnight on the morning of February 28th, 2019, 12:0000 a.m. Okay, so it's the early morning of 12/28. Okay, so it defaults, if I don't specify, it defaults to midnight or to early morning. Same thing with day 2, 12/28, 2020 at early morning, midnight that day. So if you see those 2 values, you think, well, obviously there is going to be like 365 days between those 2 dates, right? Because it's, you know, a year, it's exactly the same date, 1 year apart, 365. So let's go down to this diff, this time span, and see, if you see in here, it is 365.000, which means it's absolutely exactly 365 days difference between those. And since there's all those zeros, it means there's no leftovers. It's not like 365 days in 3 hours or something. It's exactly 365 days. So cool. We know that we've got 365 days between those 2 dates. And if we dig down into this diff time span object, you can see there's a lot of properties associated with this that give you a lot of data. So for example, the days value is 365, which we already know. And it's got no additional hours, milliseconds, minutes, or seconds. It's exactly 365. So if there was like 365 days and 3 hours, you would expect a 3 here. But we have specified exactly midnight on both days. So there's no leftovers. So you've got the total here in terms of days plus hours plus minutes plus seconds. Down here, you've got more information. You can get the time span or the interval in terms of days. You can also get it in terms of hours. So for example, 365 days, assuming 24 hours a day, 24 hours times 365 gives you 8,760 hours. So that 365 days is equivalent to 8,760 hours. So it also gives you the answer in hours, and then in milliseconds, and then it's 525,600 minutes. If you ever wanted to know how many minutes in a year, 525,600. So it gives you a lot of good data. Now, if you look at this, you can notice that it only goes up to days, all right? It gives you seconds, minutes, milliseconds, hours, and days, but it doesn't say weeks, and it doesn't say months, and it doesn't say years. So keep that in mind. As we mentioned before, the stuff you can rely on is 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week. And you can see that this time span doesn't go much beyond this. It doesn't get into months and years. And as we said before, there's probably a good reason, because when you get into months and years, it can be all over the place. Now that we know there's 365 days between those two dates, let's do it again. I'm going to shut this down. Let's try it again for let's say let's take it a couple days later and go March 1, 2019 and March 1, 2020. And again, same date, we're going to expect 365 days. Let's take a look just to verify. And we've got our 3/1/2019 at midnight, 3/1/2020 at midnight. And the diff is, wait a minute, 366 days. How can that be 366 days? We thought it was 365. Well, again, as I said, when you're talking about how many days in a year, you got to be careful. And that's what we're talking about here. 366 days in this year between March 2019 and March 2020. And the reason is because of a leap year. If you weren't aware, in 2020, they added a day to the normally 28-day February. It was 29 days in February 2020. So they added a day, which means there's 366 days in that duration. So what we can do to prove that, normally there's only 28 days. So let's say 2/28 to 2/29 to see if it will accept this 29th day, which doesn't normally exist. So let's run it, and wow, it seems to work. It says, yeah, there was a 29th day in 2020. So this time span function in C# is aware of leap years. It knows that there was actually 366 days between these two because it knows there was a 29th day in February. So again, it is smart enough to know how many days in a year. It knows about leap years. But beyond that, you're going to have to figure it out yourself. If you're talking about months or years, you're going to have to make sure that you are aware of the wide variations in leap years or time zones or whatever. Okay, so now what I've done is I have changed the two dates that I want to check the time span between. One of them is March 16th, 2017, and the other one is February 12th, 2020. And you can see just by inspection, this isn't quite 3 years of difference, right? Because we're going from March to February. So it's going to be 2 years and something, right? So let's run this and see what we get. And you can see the answer is 1,063 days in that interval. And we can pretty much rely on that because we know that this time span is familiar. If there was a leap year, it knows about the leap year. So now, let's say we want to figure out, maybe we want to figure out how many years plus how many days or how many weeks or months or whatever. So I'm going to run this again, put a breakpoint, and you can see the difference shows 1,063 days. And again, we're starting at the same midnight, so there's no remaining hours, milliseconds, or seconds, but it's 1,063 days. So the question is, first, Okay, we want to know how many years that is. Well, like I said, when you're talking about months or years, the alarm bell should go off and the light should flash because it's unclear what a year is. We're getting days, but how many days in a year? Now, if you decide that you can accept 365 days per year, then what we can do is we can say double years equals diff dot total days divide by 365. Okay, so we're going to get a double, so it's going to have the remainders and everything. So let's also add years, and we should get a printout of how many years between those two dates. So we'll run it, and you can see it's 2.911 years, which is 1,063 days, okay? So it's almost 3 years, but it's got all of this. So what we can do is we can say, okay, it's 2 years, and then we can figure out how many days are remaining in this, 0.91 years, okay? So now let's say we want to calculate how many years and how many days remaining. We know it's going to be about 2 years and then maybe 9/10 of a year, which is 300 and something days. So the way I can do that, there's a bunch of ways to do it, but I just have my double years equals the time span total days divided by 365, and that will give us the 2.91. And to find out the days, what I've done is I've taken that same total days, which is 1,063 or whatever, and I've done a modulus to get the remainder. So I will get the 0.9 whatever coming off this, and that will give us the number of days. And what I've done down here is to put the years in just the, in this case, I just want the 2. I don't want all the decimal points. I cast it to an integer. And then I've got the days here, which is the total days modulus 365. So we should get 300 something days. So let's run this. And here we go. We've got 2 years, 333 days in that interval. Okay, so that makes sense. So again, you're going to have to do a little work to figure out the years, and you're going to have to make some assumptions. Now, one thing I want to mention, if you are working with dates and times, there's a really great website. I use it a lot. It's called timeanddate.com. And here it is. It's got a bunch of calculators. The one you can use when you're doing these, to verify your code is this, where you count the days and you can put in a start date and an end date, and it calculates the duration between those dates. Really wonderful. It's got a bunch of other calculators that you can use. So anyway, timeanddate.com, I use it a lot. Okay, so the next thing I want to talk about briefly, it's a very complex subject, but I want to get the concepts of talking about clock time. Now, as you may know, if you are, for example, here's Google Earth, one of the greatest applications ever written. If, say, you're on the east coast of the US, you're in New York, and you look at the clock and it says 3:49 p.m. And let's say you get on the phone and talk to somebody who is in Los Angeles, California, and they ask you what time is it. You say 3:49 p.m. and they say, no, it's 12:49 p.m. And that's because there are different time zones, okay? And that depends on daylight saving time and where you're located and everything else. So, and you can ask somebody over in India, what time is it? And they'll have a completely different time. So the clock time varies, as you know, all over the place. But long ago, they decided to have a common reference time that they could refer to, so that everybody, no matter where you are, you can say where you are relative to this reference time. And you can look up the history, but basically it involves this longitude, and it is a clock time at this location on the globe, and it is relative to Greenwich, England. Okay? Relative to Greenwich, England. And here's Greenwich, England, just outside London, or in London. And the time on that meridian, or that longitude, was referred to as Greenwich Mean Time. So it's the time at this place, and you could always refer to this if you wanted to be talking in the same time relative to everyone else. You refer your time zone to Greenwich Mean Time to get a uniform reference time. Now that has been superseded by what's called UTC, or Universal Coordinated Time. So what I'm going to do is jump over to this, I mentioned before, timeanddate.com, and you can look at the UTC. You can look at a clock with UTC on it. And this UTC basically ignores any daylight savings time or time zones. It's just a fixed time that never changes based on the time of year or anything else, or location. So again, it is the successor to Greenwich Mean Time. It's called Universal Coordinated Time. And it is a great way to refer to a single reference that everybody can refer to that is uniform and doesn't change. So now what they've done in .NET and C# to recognize this challenge with time zones and having a uniform reference is they have introduced this DateTimeOffset. And that functionality is aware of time zones, and it's aware of this UTC, or what used to be called Greenwich Mean Time. So I'm going to uncomment this, and you can see it's very much like the others. What I'm doing is I'm taking a date time. In this case, I'm taking the day 1, which is March 16, 2017, and putting it into this DateTimeOffset, and it will tell us a bunch of stuff about that date time object, including the difference between the time and the UTC time. So the time based on location and time zones. It knows all about time zones, and it's got a lot of internal knowledge about times, so that it can help you figure out clock times. So what I'll do is I will run up to the breakpoint, and here you can see here's my day 4, which is the daytime offset for my day 1, and it says March 16, 2017 at 12 a.m. It's 4 hours difference from UTC, okay? And if I do a drop down, you can see I've got all of this information. It can tell us what day of the week that was. It can tell us the clock time, date time, hour, day of year. It's got a lot of information, and down here it's got UTC date time. Okay, so a midnight on 3/16/2017 is actually 4 a.m. because it's 4 hours ahead in this case. So again, this has got a lot more information than date time, because it recognizes UTC time along with time zones and that kind of thing. So again, like with anything, the functionality exists with this daytime offset, and like with anything else, if you don't need it, then so what? But if you need this kind of functionality with UTC and everything, it's there for your use. So anyway, I think that's it for this one. I hope it helps. Again, if you like this, hit the like button and the subscribe and the bell notifications, and especially let others know if you think this would be beneficial to them. Anyway, take care and have a really good day. Thanks.